Hello. In this video, we're going to look at an interesting application of logarithms, and in particular, looking at stuff dealing with money. So suppose you have $5,000 and you deposit it into an account that earns 4% compound interest, and the compounding is done annually. You want to have $5,624.32. How many years will it take to get there? Now, this is a common question. Normally, you wouldn't ask for maybe $5,000, but you might want to know when you have $10,000, $20,000. Maybe you're thinking about retirement and you're thinking, okay, I know I want this amount of money when I retire. How long is it going to take? How many years? You have a certain amount of money that you have in mind that you'd like to have, and you'd like to know when you're finally going to get there. So this question, of course, uses the compound interest formula. If you remember, it's the amount you're going to have is equal to the principal, 1 plus the interest rate, divided by n, which is the number of compounding periods, to the power of nt. Now in this case, because it's compounded just annually, that means n is going to be equal to 1. The interest rate is here as 4%, so I is going to be 0.04. We have to put it as a decimal. The p is 5,000. That's the principal that you're starting with. And the amount that we want is listed over here. So we can plug everything into our formula, and we're going to get 5,624.32 is equal to 5,000, 1 plus 0.04 divided by 1 to the power of 1 times t. So notice the t, the time, is unknown, so we're going to leave that as a variable here. And well, we've got 5,624.32 equals, I guess I could simplify this as 5,000. 0.04 divided by 1 is just 0.04, so this would be 1.04 to the power of t. Now, what we're going to do here is just do a little guess and check. So we're going to guess and check, see how many years it's going to take. So we need a good amount of money, so let's say maybe 4 years. So if we set t equal to 4 years, we're going to go ahead and crunch this on our calculator. 5,000 times 1.04 to the power of 4. And if I do that, I'm going to get a value of 5,849.29. Now that means after 4 years, I actually have more money than I needed, so probably a little less than 4. Let's try 3 years. Maybe it's only going to take me 3 years till I get that a value that I want. So go back in your calculator, you type 5,000 times 1.04 to the 3. And we get 5,624.32. All right. So the time is 3 years. Now, this works pretty good if the number ends up being a whole number for a year, but it's a little bit like, what if we were talking lots of years? What if the number we knew was somewhere between 30 and 40 years? We don't want to guess and check all of those numbers. And so obviously the question here is, what if you didn't want to use guess and check? Is there some way to solve this equation? We have 5,624.32 equals 5,000, 1.04 to the t. Now, we could do some basic algebra stuff here. We could divide by 5,000, right? We're trying to get the t all by itself. Divide by 5,000. We got to be a little careful here because we don't want to lose any of our decimals. So if we write this as an actual number, we need to use all the decimals. 1.124864 equals 1.04 to the t. But the problem now is getting that t by itself. Normally in algebra, we might divide something, subtract something, multiply something, but there's no way I know of getting that t out of the exponent. You could try to do a same base and then drop the base, but that doesn't seem like a great idea because, common base of 1.04, these aren't even whole numbers. I think the best move here is to take log of both sides. What we're going to do is log this side and log this side. Log both sides. Now the reason why I think that's so useful is because if I have log of 1.04 to the t, there's a very special move that logarithms allow you to do. The exponent can come on down and become a coefficient. Now on this side, I'll still have log 1.124864. Let's move up and make a little space here. So this means that I have log of 1.124864, some terrible number, but our calculator will handle it, equals t log 1.04. And if we look, by taking the t out of the exponent and down to become a coefficient, we can now divide out the log of 1.04, just like we divided out the 5,000 in our previous example. And that cancels, and so we have t equals log of 1.124864 divided by log of 1.04. Now, this is a lot to type into your calculator, but we were able to isolate for the t, and that's really, really good news. If I type it in, I should get an exact value of 3, or 3 years. So the technique we did here was we isolated until we had a single power right here. Then we take log of both sides, and then, of course, we bring down the variable. And we bring it down using that wonderful, wonderful log rule that the exponent can come down as a coefficient. Okay, so let's go ahead and try another problem. You invest $2,000 in a retirement account with a fixed annual interest rate of 4% compounded 2 times a year. How long until you have, say, $3,000? Now, I'd like you to pause the video and give this a try. We're using the same formula as before. So if you need help, the formula is A equals P, 1 plus I over N to the NT. You would be given this formula on a test or on an exam. So go ahead and use this formula, plug in the numbers, solve for T, and see what you get. All right, so assuming you gave this a try, we want to have $3,000. So that goes on the one side. We have $2,000. We know we're getting 0.04% compounded twice a year to the power of 2t. Now step 1 is to divide out that 2,000. It's going to give us 1.5 equals 0.04 divided by 2. That'll be 0.02. So 1.02 to the 2t. Now I log both sides. So log of 1.5 equals log of 1.02 to the 2t. I bring down the 2t. Give me log of 1.02, log of 1.5. And now I need to isolate for t. So I can divide both sides by 2. That'll cross off the 2. And I can also divide both sides by log of 1.02. So that's going to give me here t is equal to log of 1.5 divided by 2 times log of 1.02. Now be careful on your calculator. When you divide by something and there's 2 terms in the bottom, you probably are going to have to put the whole thing in brackets. Again, unless you have the Mr. Peters approved calculator, in which case just type it in exactly how it looks and everything should work out great. So you type it all in, might need a couple extra brackets. I think the calculator often wants you to have brackets around your logs. And that should give you 10.238. So 10.238 years until you have the amount of money you want. It's not really a whole number of years, and it'll be clear on the question whether it says like round to the nearest year or if it says just leave it as a decimal. We'll just go ahead and leave this as a decimal right now because it just said how long. It didn't necessarily say maybe how many specific years. So this is good for now. All right, let's do another one. Again, I'll put the formula down. A equals P, 1 plus I over N to the NT. Go ahead and pause the video and give it a try. Okay, so the amount we want is $100,000, and we're investing $7,000. 1 plus 0.06 over 12 to the 12t. Now we do need to be a bit careful with that decimal when we divide it by 12. we're going to get, depending on how your calculator is set up, it might give you a weird like scientific notation number. It's probably because your norm is not set up great. And so you have to go into calculator and change things a little bit. If you try to type in the 0.06 over 12 and it doesn't give you 0.005, okay, because that's what the number actually is as a decimal. If it gives you some weird thing, like 5 times 10 to the negative 3, this is kind of weird. That's because your calculator is not set up properly. So what you need to do is go Shift Setup. So go into Setup, Setup. Then you need to go to 8, which is norm. And then you need to set it to norm number 2. So norm 2, and then it should come out as a 0.005. All right, so with that out of the way, we're going to go ahead and write this. First, we could divide out the 7,000. So that's going to give us, let's see. My calculator just leaves it as 100 over 7. I think that's better than doing any rounding. This will be 1 plus 0.005 to the 12t. Now 1 plus 0.05, that's going to be 1.005, 12t, 100 over 7. And we're going to log both sides. So that's going to give me log of 100 over 7 equals 12t, log of 1.005. Okay. Let's go ahead and divide by the 12t, or the 12 I should say, and divide by the log 1.005. Finally, that's going to give me t equals log 100 over 7 divided by 12 times log 1.005. So you should get 44.432 years. Now, if it was asking how many years, so this is just if it says how long. If the question had said something different, so if it said something like how many years, it might say how many years until you have at least 100,000. And so if you notice, after 44 years, we would have just under 100,000. That's why we need an extra 0.4 of a year to get up to 100,000. And that would mean that to get at least 100,000, we would need to go up to the nearest whole number. So the answer then would be 45 years. We're not really rounding up. We're just kind of going to the next whole number because 44 years will be too little. 44.4 is exactly enough. And so 45 will get us to at least 100,000 because it's like you can only pick a whole number year in this kind of question. And then you can't pick 44 because it's too low. So the next number you got to pick is 45. Now, just to talk about this a little bit, this is pretty incredible. If you start with just $7,000, which is kind of what you could make if you worked for, a summer or two, and then you put it in a bank at 6% interest, which is actually on the low end. Often, if you're investing a little more aggressively, you can get around maybe 8%. But we're kind of using conservative numbers here. So $7,000, which is just, a summer or two of work, at 6%, which is a very reasonable interest rate, you can get $100,000 in a mere 45 years. Now, you might say, well, Mr. Peters, I don't have 45 years. Well, you sort of do. I know you're young right now, but 45 years from now takes you to about 65. And so if you took your money from a couple summer jobs and just put it away and invested it, when you would retire, you would have $100,000. So it's sort of like working for the summer doesn't make you 7,000. Working for the summer makes you 100,000. To me, I think this is pretty remarkable. It really shows that power of compound interest. And it's certainly something to think about when you're looking at what to do with your money. I would, in some ways, recommend that you start investing and you start saving young, because the power of compound interest really takes effect over a long period of time. It's not the most flashy way to make money, right? You're not going to the casino and double or nothing. But if you leave your money and you let it grow slowly over time, you'll be quite surprised 45 years later when you haven't had to do any work and your small $7,000 has multiplied and multiplied into $100,000. All right, let's go ahead and do another question. We've got Maria investing $6,000, fixed annual interest rate of 9%, compounded 4 times a year. How long will it take for her balance to double? So just as a little hint, if you want it to double, you have to go from 6,000 to 12,000. So that's just the little twist there. Go ahead and pause the video and give it a try. Okay, so we do 12,000 equals 6,000. 1 plus 0.09 over 4 to the 4t. Now again, when we do that 0.09 divided by 4, we have to be careful. We want to make sure we have all the decimals. So 0.09 over 4 on my calculator is 0.0225. So we need all those decimals when we add it to the 1. All right, let's go ahead and divide the 6,000 first though. 12,000 over 6,000 should just be 2. And this will be 1.0225 to the 4t. Take log of both sides. And then move down that 4t. And then we're going to isolate for the t by dividing everything out. Divide by 4, divide by 4, divide by log of 1.0225, log 1.0225. And so we get t is equal to log 2 over 4 log 1.0225. Let's go ahead and type that in on our calculator here. Should give us 7.788 years. And because it says at least double, let's go ahead and just round that up and say t equals 8 years. So again, it's pretty remarkable. You could double your money by going to the casino and putting it all on black, but you could also lose your money doing that. Here, it's a very safe way to double your money. Just take your money, put it in an investment account, and wait for a total of 8 years, and then you'll double your money. Again, it's maybe not the most exciting way to double your money, but it's much more reliable than other methods. All right, let's go ahead and take some notes on this. This is using logarithms on compound interest problems. Okay, so if we look at our formula, there's different letters that you could solve for here. Okay, and if you need to solve for A, this is just plug it in. Okay, that's super easy to solve for A. That's how the formula is set up. If you just plug in all the numbers, you'll get A equals. If you need to solve for P, you just need to use basic algebra. Basic algebra. You plug in everything, P is left over, divide it out, and solve for P. If you need to solve for I or N, maybe take another math course. These are more advanced, and we don't actually work at solving for them, just as a pro tip. But if you need to solve for t, yeah, that's what we did today. This is where you use logs. The idea here is that because the variable is in the power, got the exponent up there, we take a log and it brings the variable down, and then everything works out great. So the technique is you isolate for the power, so that way you've got like some number raised to some variable, and then you log both sides. so that the number has a log and the t pops down. So again, I'll give you here a basic example. Let's say you had 4 equals 1.0, let's say 8 to the power of 12t. And the question is solve for t. In this case, I've done all the plugging in for you. You just need to do the log steps and solve for t. So go ahead and pause the video and give that a try. All right, so you take log of this side, log of this side. Then you bring down that 12t, leaving you log of 1.08, log of 4. Divide out everything by 12, and by log of 1.08, log 1.08. So we get t is equal to log 4 over 12 times log 1.08. Often your calculator needs brackets around the logs. Let's go ahead and type that in on my calculator, see what I get here. This should give you 1.501 years. Or another way to think about it, if you want, is if it was a whole number of years, you would have to round it up to 2. So this, for practice, you can work on Unit 9, Worksheet 9. And a thing to remember that might be worth just writing down is that if you get your time equal to 3, then that's just a year. It's probably in years, or it might be in months. But if you get time equal to 3.412, I guess that is a year. But if they ask you to like the nearest whole number year, you're probably going to have to go up to the next number and go to 4 years. Just because 3.4 isn't a whole number of years. All right, hopefully you enjoyed this video. And as always, thanks for watching.